I want to talk about rational functions. Rational functions are functions that can be written as fractions of two other functions. So you can see in my example that I wrote here, I've got a line, 2x plus 8, so a linear function with a y-intercept of 8 and a slope of 2, divided by another linear function with a y-intercept of 1 and a slope of 1. So a rational function is any function that basically looks like a quotient or fraction made up of two functions. All right? So first thing I guess we should talk about is just how we evaluate these. Now, it's not going to be any different than how we evaluate something else, something that isn't rational. If I say, what's f of 2? You'd say, well, I'll plug in 2 every time I see an x, like that. So the top, 2 times 2 plus 8 is 12. The bottom is 3, so that's 4. If I were to say, well, what's f of 0? 2 times 0 plus 8 over 0 plus 1 is 8 divided by 1, or 8. So please note what we just found when x is 0, y is 8, we just found the y-intercept of this function. Okay, if I said, what's f of negative 1? So 2 times negative 1 plus 8 over negative 1 plus 1. Well, the top is 6 and the bottom is 0. And herein lies something that's different and interesting about rational functions. We run the risk of dividing by 0. And you can't divide by 0. This causes an error to happen. Let's look at what happens in our graph when we divide by 0. So I'm using Desmos and I've graphed this function. And I think first thing to point out, because I said we found the y-intercept when we plugged in 0. When x is 0, we found 8. You can see it's 8 right up here. There's my y-intercept. But when I plugged in negative 1, I ended up dividing by 0. Well, here's negative 1 right here. We call this an asymptote. In this case, because it's up and down, it's a vertical asymptote. A vertical asymptote is a number that we would plug in that would cause our function to be dividing by 0. And what happens is that as you plug in numbers closer and closer to negative 1, but just above negative 1, we end up dividing by very small positive numbers, and therefore we get very, very big. If we plug in numbers that are very close to negative 1 but below negative 1, and we plug in those numbers, we end up dividing by very, very small numbers that are negative, which gets us large negative values or very, very negative values. So that's what's causing that to happen. So this is something that we're going to study with rational functions, and the idea behind asymptotes, where the function kind of either levels out or has some kind of error that causes this kind of behavior that's going towards infinity. So in terms of just evaluating, that's no different. You plug in the value. Okay? It might be more complicated than my example, might have more x's or x squareds or something. The process remains exactly the same. The thing to be worried about is if I plug something in that causes me to divide by 0. Because if I plugged in a number like, let's say negative 4. Let's say I said f of negative 4. 2 times negative 4 plus 8 is 0. Well, negative 4 plus 1 is 3. I have 0 divided by 3. Well, 0 divided by something is 0. You can see here's x equals negative 4. And in that case, if I figure out what gets me an answer of 0, that's the x-intercept. So plugging in 0 gives me the y-intercept. Finding what makes the function 0 is the x-intercept. If this video helped you, please like and subscribe for more math help.